Before we start on the notes on this gold paper, there's some exponent rules that we've forgotten that we need to write down here in the bottom of this first page of our gold notes, underneath that box. Right down here at the bottom, here is some exponent rules that we need to write down. Any number raised to the 0 power is equal to 1. That's an exponent rule we seem to have forgotten. Any number raised to the 0 power is equal to 1. Any number raised to a negative power is a reciprocal. If it has a negative power, that's the same thing as having a positive power in the denominator. And also it appeared in my previous class, forgot this one. Any number to the 1/2 power, a 1/2 power is the same as a square root. Now, if we take this and make it into log form, log base A this becomes the exponent, and this goes right here. A to the 0 power is equal to 1. It's the same rule written in log form. Okay, let's see. This one would be log base A of the reciprocal is equal to a negative power. And we're just leave that one. So that's the same rule written in log form. Those are reminders of previously learned rules. Now, in order to help us solve our log equations, we are going to need to know this power property of logs. There are some other properties of logs that we're not going to learn in this class that you're going to learn in pre-cal. But we're going to need this property in order to help us solve equations. When we have a log and this number has an exponent, this exponent can come out in front of the log. That is the power property. Or it works the other way around. If you have this number out in front, it can come back over here as an exponent. I can do it either way depending on what I need to do to solve the problem. So let me show you an example. You see where this 3 has an exponent, x to the 3rd power? This 3rd power can come out in front. That's what the power property tells me. Well, why would I want to do that? Well, it's going to help me solve problems in a minute. Did you get that one written down? See how it has an exponent of 2 here? This exponent of 2 can come out in front if I needed it to in order to solve a problem. If it was already out in front and I needed it to, it could go back over there and become the 2nd power. The power property says if it's a property, it can come out in front. If it's in front and I need it to, it can go back on as a power. Whichever way helps me solve the problem. This doesn't have an exponent. But as we just wrote on our previous paper, a square root is the same as a 1/2 power. A square root is the same thing as a 1/2 power, and now the 1/2 power can come out in front. And this is going to help me solve log equations. Now, on that blue paper that we were just working on, each problem had how many logs? Just one. The problems that we're going to look at today are going to be like this kind of problem. How many logs? 2. A log on both sides. And if I have a log on both sides, then it's as if the logs on both sides cancel, and I just have to solve this part. If the logs have the same base. It gets more complicated if they don't have the same base. But if I have the same log with the same base, then I can just solve this part. That's the law of equity. Now, is there anything out in front of either of those logs? Because when we get to this first example, do you see that there's something out in front of this log? So there's got to be something. We're going to use the power property first and then the law of equity, because I need a log equal to a log with the same base in order to use the equity rule. So using the power rule, this becomes 3 to the 4th power. The power rule says numbers out in front can come back onto the 3 as an exponent. Not that much. Logs are the same. They have the same bases. Then it's as if those cancel out, not actually technically mathematically correct to say that. Can you solve that? What is 3 raised to the 4th power? We have this 1/3 out in front, so it's going to have to go back to the x as a 1/3 power. The logs are the same, the bases are the same, so the 64 is equal to x to the 1/3 power. How do you get rid of a 1/3 power? What's the opposite of a, let me say it correctly, what's the reciprocal of 1/3? 3 or 3 over 1. So I raise both sides to the 3rd power. Because a power raised to a power, those multiply together, those cancel out. 64 raised to the 3rd power is a very large number. 2, 6, 2, 1, 44. Because 64 times 64 times 64 is going to make a very large number. Questions? Now, on this one, do we have any numbers out in front of the logs? No. Do we have the same base on the logs? Same base, so basically the log base 7, I don't have to worry about that. I just have to solve this. This has a denominator of 3. How do we get rid of denominators? We're going to multiply both sides of the equation by 3 to cancel out the denominators. Then divide by 2. Is this actually a little bit easier than what we were doing yesterday with a log on one side? I think logs on both sides are a little easier. We don't have any number out in front of the log. Nothing that we have to use the power rule on. And so the log base 7 for all practical purposes cancels out. And then you solve that. Go right. What do you do, though, if there's a number out in front of the log? So this would be log 5x equals log base 100 to the 1/2 power. Same log on both sides, same base on both sides. Don't have to worry about log 5, it's the same. And so is this what we need to solve? What is 100 to the 1/2 power? It is not 50. It is the same as a square root. A 1/2 power is the same as a square root, and so the answer is. Or you could put this in your calculator, but make sure if you put it in the calculator that you put a parentheses around the 1/2 if you're going to put it in the calculator like that.